digitization projects have multiple goals. However, what they all have in common is to create a digital copy of the original. What characteristics must a digital copy have in order to come as close as possible to the reproduction quality of the original? The quality of digital images can be assessed on the basis of 5 characteristics. First of all, we have the shape. Size, aspect ratio, distortion must correspond to the original. Then we need the detail representation. Sharpness resolution must be good enough to reproduce all the nuances of the original. Beyond that, we then have contrast and tonal gradation. The exposure must be correct. The tonal gradation, that is, the grey levels in the original, must correspond to the natural reproduction, and based on this, the colour reproduction can also be rated. This must also correspond to human perception. And last but not least, we have homogeneity. Homogeneity means that the aforementioned properties, the uniformity of the reproduction over the entire image is given. An objective judgment of the quality of the digitized images is therefore possible. Image quality is measurable. First of all, we have to acknowledge that image quality is measurable. That means the previously mentioned criteria such as resolution, homogeneity, sharpness, these can be measured. The measurement methods are described in various ISO standards. And in summary, how these are evaluated, that is the ISO standard 19264-1 2021, which is about how digital is described in terms of its image reproduction. In addition to this standard, there are so-called imaging guidelines. In practice, the FAGI guideline for the US and the Metamorphosi guidelines for Europe. For the application, quality parameters, that is, measured values, are then specified, by which we can judge a digital copy, how good or how bad the whole thing is. How can the individual parameters be measured in practice? And what conclusions can be drawn from this? The readings of the quality parameters can be determined with the help of a so-called UTS Test Target. The test chart is digitized with a scanning system and evaluated with analysis software. The results can then be compared with the set specifications for image quality. In this way, one obtains a quantitative statement on the image quality achieved and thus also a statement on the performance capability of the scanning solution used.
And that's everything we need. We hit the green button and we let the software do the analysis. After a while, we get in the center of the screen the quality results. In that case, everything is green, everything is passed. If we want to see further details, on the right hand side of the screen, we get a summary of every single measurement. And beside that, we get all the details for every single measurement which was taken on that target.
The technical approach presented should be carried out at regular intervals. Usually this is done at the beginning and at the end of a digitization project. In larger projects, at defined intervals such as the beginning and end of shifts, as well as when there are upcoming changes in the project process. Recently, a solution has become available that considerably simplifies and expands this random inspection. It allows for the inline quality control to be conducted automatically during each scan.
Your need for this is Seuchel OmniScan 12.12, SR2 in the latest version. Then you need Seuchel OSQM tool, and very important that the optional feature SW259 image quality control on the fly. This has to be enabled. This is an option for OSQM tool. And last but not least, of course, you need an object level target like that one here, Golden Thread target from Don Williams, or the target number T263 from Image Engineering. So since we know what it needs, we want to see how it works. So here we have a typical job for a library, a book, left side and right side, 2 pages. And in addition to these 2 pages we want to save, we have defined a third clip which contains the object level target. The object level target we have arranged in the focus level on the scanner in the same area then the book is digitized. If we now look into the settings of OmniScan of the clips, then we can see that the clip 1 is coupled with the object level target of clip 3. The clip 2 is also coupled with the object level target of clip 3. And last but not least, the clip 3 is the object level target itself. So it means it is indicated as an object level target. This clip will not be saved, it will just taken for analysis. If we now run the scan, the 2 pages will be scanned, the 2 clips will be stored to disk, and the object level target will be sent to our scan tool for image quality analysis. And it immediately comes back with an information if the quality level is passed or if the quality level has failed. If it's passed, then we get a green indication here underneath our thumbnails. So the number of the thumbnail turns into green, and also there is a small green tick box in front of the number of the thumbnail.
The fact that I can check the most important quality features in every scan with the inline quality control gives me 100% certainty of the results in my digitization. Technical approaches and reliable analysis software ensure consistently high image quality during digitization, and this is conducted in a continuous productive process. Time-consuming rescans at a later point in time are thus completely avoided, which in turn has a positive effect on the overall cost of digitization projects.